Hi math friends, let's check out our study guide here on scatter plots. So we've got a scatter plot here that's already made for us. It says it shows how the age of eight children and their height. So I've got my x-axis and my y-axis. Important to remember and mark on there. What is the meaning of the point 4.7, 3.2? Well, if I follow in order, x is for the age and y is the height. So I want to look for a statement that matches that. 4.7 for the age. 3.2 years old. No. That doesn't make sense at all. 4.7 years old. 4.7 years old. Now I want my height to be 3.2. I got to do the one that has height. So that would be C. Is the association between the child's age and height positive or negative? Let's look at our scatter plot. Remember, I can make an ellipse around that. And if I think of a line going through the middle of that, okay, generally it does do that. It increases. So that would be a positive association. Remember, that's also the type of slope that it would have. So we can say positive association. Right? Now we also want to be able to check out C. It says state the association between the child's age and height, which is exactly what we see. As they get older, they get taller. So as the child grows older, they get shorter? No. Older, they get taller? Yes. As they get older, their height does not change? No. Okay, it's got to be B. Important to go through all of your answers because sometimes it's choose the best answer. And this one only had one correct. Alright, checking out number 2 together. We've got, after taking a test, 25 students were asked how many hours of sleep they had the night before. And the scatter plot shows this data. Is there an outlier here? Well, as we get more sleep, test score generally goes up because your brain's more ready. Outlier is far away from our trend, right? I'm going to circle that trend here. Right? So my trend is going this way. Here's my outlier, 960. We can say yes. Okay, next question is about the outlier. There is an outlier, so we don't do that. My point is at 960, so it cannot be 60, 9. So what makes it an outlier? It varies or it follows? It varies from the overall pattern. Last question, scatter plot represents 25 students, but there's only 21 points. So if you go through and count these, there's 21 points. When this happens, remember, I could have 5 hours of sleep and I could score 76%. Somebody else could do the same thing, right? It is possible. So if I have multiple students scoring the same thing, that's exactly going to happen. Okay? Not incorrectly counted or anything, but they scored the same. Alright, let's look at number 3. This one gets a little bit heavier. We've got all these points. We've got a line of best fit here with temperature and sales. And we're being asked to, look up here, write an equation, right? In y equals mx plus b. So my suggestion is to choose some points that are on the line. I don't have any that are on an exact like crosshair or grid line here. So I'm going to choose. I'm going to take this point. Okay, this is 16.5 comma 321. And I know that because it's in my table here. It's exactly on the graph right here. Okay, I've got another point right here. Just about right there. That would be this one right here. 22.1 comma 525. Now I'm going to use those to get a slope. So y2 minus y1 over x2 minus x1. That's how I find my slope. 525 minus 321 over 22.1 minus 16.5. I'm going to use my calculator to subtract those. I get 204 over 5.6. I'm going to divide those. 204 divided by 5.6. And I get 36.43 about. Now I need to find out my y-intercept. So I'm going to choose my lower point, 16.5. So in y equals mx plus b, substitute 321 for y, use my slope that I just got, and then use my x value, and then a plus b. Now I have to solve this for b. I'm going to do this work over here. Okay, So I've got 321 equals, multiply these together. I'm going to do that on my calculator. I get 601.095 equals B. And now I subtract that number. So at the end I have B equals negative 280.095. So my equation, y equals 36.43x minus 280.095. I'm going to use that equation to find the number of sales for a temperature at 16 degrees Celsius. So when I have this equation, I'm going to go y equals 36.43 times 16, that's the number I'm being asked to use, minus 280.095. This is all calculator work. Multiply these together, subtract this. At the end I get 302.785, because this is money, $302.79 I'll round it to. Okay, explain why the estimate is reasonable for the problem. We can say we used our equation and it follows the overall trend. Number 4 has us make our own scatter plot, so a little bit more involved this time. We have to plot all these points. Okay, let's go ahead and do these, 250 and so on. Is plotted. It kind of looks like it's going this way, so remember to make an ellipse for your data. I'm going to use a straight edge, draw a line through the middle of those as best I can, which after you have that ellipse drawn should be a little bit easier. Alright, and now we have to look at this. Based on this, what happens? As the time decreases, the height increases. So time decreases. The time increases here, though, right? As the time increases, the height decreases? No. There's a weak association in the data. So, like, these points are all really far away from each other? Not really. The data has a positive association. That's what we just drew. Part D. Okay? Now I'm going to try to find some points that are pretty exact on here. I'm going to go ahead and use this one. So I'm going to use 145. And this is like just a tiny smidge above 60. We got 5, look at this one, 561. Now when you're doing this, because you had to draw your own line, if your points are a little bit off, but they're close, right? Like if you had exactly 560, and if you had like 1 and 42, something like that, you're going to get an answer that's close. All right? We're going to prove that here too. So let's do our slope, y2 minus y1 over x2 minus x1. Okay, 61 minus 45 over 5 minus 1. So I get 16 over 4. If I divide that, I get 4 for my slope. Now on yours, you might have something different, right? If you get like a 4.2 or a 3.9 or 3.8, like that's where we should be. We're all close to each other. All right. So let's check out how we do the next part. Y equals mx plus b, same as the previous problem. I'm going to choose my lower point, substitute in those values, multiply, and then subtract. So I've got 41 equals b. My equation then is y equals 4x plus 41. Okay, now this should be close to yours. If you use different points, you might get a 3.9 here, you might get a 40 here, you might get a 42, okay, but it shouldn't be really far off. If you get like 6 here and like a 50, that's way off. Alright, we're going to use this one for our next part. In general here, The slope represents the approximate amount of, this is an increase, right? It's going up, in the amount of height per time. So how much height increases per each minute or each hour. There weren't units on here, so it's just per time. Use your equation to calculate the height at a time of 3. So our equation is y equals 4x plus 41. Okay, we want our time to be 3, so 4 times 3 plus 41. We've got 12 plus 41, so our height is 53. And we're never given feet or inches or miles or anything here, so our answer is simply 53. All right, our next one here, there might have been a little error on this. This should say cookies. Okay, and over here, this should also say cookies. Okay, Taylor's baking cookies for a party. Number of cookies is determined by the number of visitors he has. So we're going to define the variables. We've got C for cookies, V for visitors. Simple enough. Now, here I got to do some thinking with explanatory and response. Do I have to know the number of cookies first or the number of visitors? Okay, so if you think about that for a minute, if I know the number of visitors first, then I bake the amount of cookies for them. So this is my explanatory variable. Got to know that first, which makes this the response. Okay, identify the units of measure. So this would be if we use like feet, number of, something like that. Simply put, number of cookies is number of cookies. This is number of visitors. It seems like a trick question, but that's exactly where we go. Would you expect there to be a relationship between the variables? Well, if we have more visitors, will we bake more cookies? It makes sense that we would. So let's write something to that effect. Yes, it only makes sense to bake more cookies for more visitors. All right, our next one is about the eruption of Lassen Peak. And we got to be really careful on this. So on this says based on the line of best fit. It's already drawn for us. Okay, what is the Na2O level when the SiO2 level is 61? So let's look at this over here. When it's 61, I'm going to go straight up. I'm going to stop at the line. Based on the line of best fit. We are not creating new data. We are using that line. Okay. Now on here, I'm going to zoom in on this side a little bit here. Hopefully this helps. Okay. I've got 3.8 all the way up to 3.9. So it actually goes by 0.02, 2 hundredths. 3.82, 3.84, 3.86, 3.88, 3.89. So right here is exactly 3.86. Okay, zoom back out. So 3.86 is what we got. Same idea for the next question. Based on the line of best fit, right? I've got this level this time at 4.1. I'm going to go to 4.1, go all the way straight over to the line, go all the way straight down. Now this one's tricky too. 65 to 67. I expect 66 to be about here, right? In the middle. So I've got 65 and 1, 2, 3. Yeah, this is like maybe 65.8 or so, because it's close to 66. So I would say that would be a decent guess there. Yeah. Do you think your predictions are reliable? We can say yes, they follow and use the trend line. Okay, so if we actually tested this in real life, it might be a little bit higher or a little bit lower. So like if we actually took the data, but it won't be way high or way low. All right, let's go ahead and look at our last page here. It says create a line of best fit on the scatter plot below. Then calculate the slope and y-intercept. Finally, write an equation. So we've got beach visitors, average daily temperature, number of visitors. Think about this realistically. As the temperature increases, are more people going to go to the beach? Yes. In general, yes. let's go ahead and circle our data best we can, right? Ellipse around that. And we're going to draw a line through the middle of that data as best we can too. Right there seems good. Okay, now remember, your line might be a smidge off of mine, but it should be pretty close, and our equations should be similar at the end. Okay, so I'm going to pick a couple points here. Since this is kind of going right through here, I'm going to choose this one. This one is about 82 and 100, just about, because it's going up by 75 here. I've also got about here. We got 94, 525. All right, now I'm going to do my slope. 525 minus 100 over 94 minus 82. So I get 425 over 12. I'm going to leave that as a fraction for now. It's not going to be a whole number, so we'll leave it like that. Let's find our b value. I'm going to go ahead and use the lower point, so 100, and then use my slope here. And then 82 plus b. Divide, multiply. I get 2,904.17. So I need to subtract that. And then I'm going to get b equals negative 2,804.17. So my equation, 425 over 12x minus 2,804.17. If you're like, why is that 2,000? Well, look over here on the graph. There's a lot of data missing here between 0 and 80. Right? There's this little break in the graph. Also, if it was 0 degrees, I wouldn't expect anyone to go to the beach. We're only looking at 80 degrees and up. All right, let's check out our last one. Identify which is the correct line of best fit. So if you just kind of look at this, B is like way above everything. So B is just wrong. But C and A both look pretty good. So what I need to do is say which one is better. Okay, which is the best answer? Circle, or put an ellipse if we're being technical, around your data points. Remember, we want that nice and tight. Okay. Now if I do that, and then I can think of, well, where's about the middle of that? A is more so going through the middle of that than C is. C is off to the side here. We want that right through that middle of that ellipse. So I'm really following A. And we'll write that for our study guide here. It goes through the middle of our ellipse. All right, so use this to help you study. Pause, rewind, all the things you need to do. You are awesome. Stay awesome. Keep working hard.